All right. So tonight we're going to get into, hold on one second. Let me go ahead and record. There we go. All right. So tonight we're going to get into, hold on one second. All right. So tonight we're going to get into, hold on one second. All all right. Making sure there's no feedback because I do hear feedback. So let me hold tight. Let's see here. Okay, there we go. All right. So, what we're going to get into tonight, well, first off, welcome everyone to the live tonight. I am Professor TK the Chemist. For those of you all that don't know me, my I go by that name because I am a chemistry professor and I do chemistry tutorials for students that need help in general chemistry 1 and 2. Since this is the summer school, I know that so many students are having trouble trying to make sure that they're going to do well for chemistry, especially those of you all that are taking chemistry this summer. So, what I'm going to do is make sure that you're on the right track because I want to ensure you that you don't have to struggle and be on the struggle bus with chemistry this summer. Now, why do I say that? I say that because so many students that are taking chemistry don't realize that there are resources available to them that they can actually use and not be afraid to utilize them. For instance, in most students' classes, they have a professor who has a TA. And if you don't have a TA, which is a teacher assistant, you have that professor who offers office hours. Now, the professor that normally offers office hours is supposed to assure that what you don't understand in class, you can get it after hours or before hours. And the thing is, closed mouths don't get fed. So if you do not reach out to your professors and ask them questions, they're not going to know that you don't know what you're doing. So the best thing that you all can do at the very beginning of any summer school session is to start off on the right track, okay? You've got to start off on the right track. So, how do you start off on the right track? You come to sessions like what I'm offering every week, and I have provided my schedule for you so that you will know when I go live pretty much from what you see on the calendar, okay? So for those of you all that are new to this live, let me go ahead and tell you all what my days are for going live, okay? So, and some of you all are going to actually get this schedule on my TikTok channel and on YouTube as well. So let me pull it up in case you do not know when I go live, okay? Because I know so many students want to be a part of those sessions, but you don't know if you're, when I actually go live. But the schedule will be pinned every week so that you will know. So I actually will do this pretty much Monday through Thursday. Okay, Monday through Thursday. And the times that I will be going live varies depending on the day of the week. Okay, depending on the day of the week. All right. So as you guys are coming in, I'm going to be going by a different schedule in terms of what we're going to be covering each week. But let me go ahead and run my schedule down to you so that you will know when I will be going live, okay? So that you will know. So Monday, Wednesday, and Thursday, I will be going live at 12 noon Eastern Standard Time, and on Tuesdays and Thursdays from 7 to 8, okay, p.m. Eastern Standard Time. So for those of you all that have caught me here tonight, today is Tuesday, you guys have gotten me here on Tuesdays and Thursdays. Now, the thing is, when I go live, I may or may not be on the same schedule as your teacher. So the thing is, you have to be mindful of what we cover during the lives may or may not coincide with what you do with your professor. All right. But the thing is, you do have access to all of my videos. They're here and they're on my YouTube channel. So tonight's lesson is going to deal with significant digits. And I wanted you guys to understand that this is pretty much the foundation of chemistry. If you do not know how to do significant digits, you will be lost. Okay. You will be lost because this is the foundation for what we're going to actually cover in General Chem 1. Now, for those of you all that are taking chemistry, if you can, if you're taking chemistry this summer, put a 1 in the chat, okay? If you are taking General Chemistry 1 this summer, put a 1 in the chat. The reason why I'm asking that question is because that's going to pretty much garner what I would be sharing with you all each week to make sure that you guys are on the right track. And the thing is, it's going to go fast paced. Now, when I used to teach chemistry during the summertime, it was one of those things where we had a test once a week. And summer school for in my area is only 5 weeks. Okay. So if it's a 5 week class, you're taking, in our normal semester is 16 weeks. You're taking 16 weeks and condensing it down into 5 weeks. So that means with this General Chemistry 1 class that I'm going to be teaching you all over the next 6 weeks or 5 weeks rather, you're going to be going at a very fast pace. Okay. But I will slow it down just a little bit to make sure that you all can kind of keep up with what we're doing. All right. So for tonight's lesson that deals with significant digits, I'm going to go over a couple of things with you. And if you have questions, of course, you need to let me know, right? So that we can make sure that we get your questions answered. And by the way, these questions are going to be on the TEAS exam, the TEAS 7 chemistry exam. So, Bean, I see that you are taking chemistry this summer. Now, when does your summer school class start? When does your class start? Because this is the thing. For chemistry, it's one, and when you're taking it during the summertime, okay, June 13th. Okay. So what we're doing tonight is going to be like a refresher course to help you at least introduce this information to you. Okay. So you're pretty much in on the right track. And I'm glad that you're here tonight so that you're able to at least kind of, get what you need for the moment. Okay. So let me go ahead and tell you a little bit about what we're doing tonight. In chemistry, you're dealing with what's called significant digits. And these rules are something that you have to learn in order to be proficient in what chemistry entails for a semester. If you don't have significant digit rules under your belt, what happens is students get discombobulated and then the duration of the semester goes downhill. Specifically, when you're getting into like adding and subtracting, multiplying and dividing. So I'm going to go through a couple of examples tonight just to kind of introduce this lesson to you. And then we're going to take it one by one when it goes through the rules for adding and subtracting, multiplying and dividing. So for just tonight, we're going to get into the whole thing of significant digits and the numbers. So what you've got here are a couple of things. Here are the facts that you need to know. All digits 1 through 9 are inclusive. They are significant. So if you have a number that's numbers 1 through 9, all of those numbers are significant. So if I give you for this example here, 354, that has 3 significant digits, the 3, the 5, and the 4. If I give you, let's say, 1,234, for instance, the 1, the 2, the 3, and the 4 are also significant. So when we talk about digits 1 through 9, all of those are inclusive of being significant. Now, here's where it gets a little tricky. When you talk about those zeros, zeros between significant digits are always significant. So this is rule number 2. Rule number 2 says zeros that are sandwiched in between significant digits are always significant. So here's an example right here. You see this number on the screen, right? 3009. Those two zeros are considered to be significant because they're sandwiched in between a 3 and a 9, digits 1 through 9. Therefore, all four of those numbers would be classified as being significant. Now, when we look at rule number 3, it changes a little bit because of the decimal that is being present. The decimal that is present indicates that trailing zeros in a number are significant only if the number contains a decimal number. So, what does that mean? If I give you the number, like in the first example here, where you get 100.0, well, the significant digit rule says that all four of those numbers are significant. So if I give you 100.0, then you have four significant digits. If I give you 100.00, then guess what? I have five significant digits. So when there is a decimal present and there are trailing zeros, then that means they all count. But you have to make sure there's a decimal present. Now, in this other part of the example, though, where you have 100, but there isn't a decimal present right here underneath that, guess what? You only have one significant digit. So that means if I give you 500, okay, without the decimal, then I only have one significant digit. But if I give you 500 with the decimal on the very end, then in this case, I have three significant digits, okay? I tell students all the time to make index cards with these rules on them so that you can easily remember them, because a lot of times students get these rules confused. So you want to make sure that you are keeping up with your significant digits rules according to what you've got, okay? Take a look at rule number 4 now. Rule number 4 says zeros in the beginning of a number whose sole function is to place the decimal point are not significant. So I know some parts of this is being cut off. So let me go ahead and scoot this down a little bit so you guys can see this. Hold on. Okay. So hopefully you guys can see this here. All right, so let me read the rule to you again. Zeros in the beginning of a number whose only function is to place the decimal are not significant. Trailing zeros are not significant. So what do I mean by trailing zeros? Okay, if they are at the very beginning of a digit, they don't count. So if you take a look here and you see that you have 0.000, okay, those zeros do not count. But the moment you get to the 7 and the 9, those two numbers do count. Therefore, you have two significant digits, okay? You have two significant digits in this particular case. All right, now, the last rule, rule number 5. Rule number 5. Zeros following a decimal and significant digits are significant. Zeros following a significant digit and a decimal are significant. So what you will notice here, when I have 0.000380, the only numbers that are significant are the 3, the 8, and the 0 on the very end. In this case, I have three significant digits. However, anyone that has 0.38000 and those zeros are at the very end, the reason why all of those numbers would count, saying that we have five significant digits, is because the zeros are there at the end, but there's also a decimal present, okay? There's also a decimal present. Now, what I'm going to do is go through these rules again, but this time with some other examples that you guys can follow. A lot of times we have to see these rules being implemented with examples in order for you all to see how simple this process can be, okay? So let me go ahead and show you all what I mean. Here are some examples. And with these examples, some of them were cut off. So let's see here. Hold tight, y'all. Okay. So what you all will have to do when you go through these examples here, I want you all to be mindful of the rule that's applied, and I will repeat the rule to make sure that you're on the right track, okay? Because that's going to be important. When we go through these examples, you'll want to make sure that you keep the rules intact, all right? Keep the rules intact. All right. So now what I'm going to show you, okay, as we go through these problems, I want you guys to tell me in the comment box. And if you participate, then I will at least know what you're saying and I can point you in the right direction. Okay. So let me straighten up some of let's see here. Okay, there we go. All right, so take a look at the first one right here. We've got 0.03. Now, when we look at these examples, what you have to be mindful of are the rules, okay? I'm going to actually go over the answers and I will explain why the answer is what it is, all right? So for this first one, 0.03, I have one significant digit in this particular example because according to the rule, whenever you have a significant digit, but it's followed after a zero, only that significant digit is what counts, numbers 1 through 9. Although there's a decimal present and there is a zero at the very beginning, the zeros do not count because there are placeholders. So only the 3 is what counts. So that's why we have one significant digit. However, let's take a look at number 2. We have 0.030. Now, in this case right here, I have two significant digits. And the reason is because the 3 that's present here and the 0 that comes after it is what counts. And guess what? There is a decimal present. And the rule says that when there's a decimal present and the 0 comes after a significant digit, that's what counts. So for your general chemistry classes and for the TEAS exam, these are the things, and for the MCAT, I cannot stress that enough. Those are 3 different types of classes that you would have to know all of this information in terms of these assessments. Okay? Let's take a look at number 3 now. 701. So that's 701. Well, in this example here, we know that the 7, the 0, and the 1, all 3 of those count. We know the 7 and the 1 count because those are significant digits between 1 and 9, but the 0 that's sandwiched in between the 2 significant digits would also count. So therefore, all 3 of those numbers are significant. So here we would say we have 3 significant digits. All right. And again, if you guys have any questions in the comment box, by all means, let me know and I'll be more than happy to help you guys out. Okay? I'll be more than happy to help you out. And if you guys can, make sure you all are tapping that screen because this is how the analytics and Tickety Talk Talk lets everyone know what we are doing here today. Okay? So the whole purpose in this is to let TikTok know, and of course, let TikTok send out the signal that, hey, Professor TK the Chemist is in the building tonight. And my goal is to make sure that we have enough students that are getting in here, getting everything that they need to be helpful, okay, for their chemistry classes. All right, let's take a look at number 4 now. We have 701.0. 701.0. Now, what do we have here? Well, we know the 7 and the 1 are significant, yes. But what we also know is that that 0 that's sandwiched in between the 7 and 1, that 0 also counts. And you know what else counts? The other 0, because there's a decimal present and is after a significant digit. Therefore, all four of those numbers would count. So in this case here, we have four significant digits. Four significant digits. All right. Let's take a look now at the next one. Number five. Number five. Okay. So in number five here, we have 5,000, but there isn't a decimal present. Now that means if there isn't a decimal present, only the five would count. Okay. Only the five would count. So therefore, we would have one significant digit. Okay. Just one significant digit. Again, I know when we're learning this information for the first time, this stuff can be kind of like, yeah, boring, boring, boring. But what I know is that this is the foundation for what you guys have to know for general chemistry. Okay? This is the foundation for general chemistry. Now, let's take a look at number six, 8,000 with the decimal present. 8,000 with the decimal present. Now, we know the rule. The rule says numbers 1 through 9 are significant. So we know that the number 8 is what's significant. Yes. But what we also know is that the zeros count as well because there is a decimal there. That decimal is like an engagement ring. It says that everything, is significant because of that decimal. And that decimal happens to come after a significant digit. Okay. So that's why all four of those numbers count. So in this case right here, we have four significant digits. All right. Number seven. Number seven. We've got 5,032.00. 5,032.00. Okay, so what do we have right here? We know that the 5, the 3, and the 2 are significant. Hey, Daphne. Okay, so you say four significant digits? Well, let's take a look at that again. We know that the 5, the 0, the 3, and the 2 count. Yes. But what else counts are those decimals, the zeros that come after the decimal, because that decimal place that's there kind of acts like an engagement ring or promise ring. Okay. That means once we put the ring there, everything is of value. Everything is significant now. So in this case right here, including those zeros on the end, this is going to give us six significant digits. So 5032.00. All right. So I hope that made sense for you in terms of, okay, Callista says the decimals confuse me. And number two, why wouldn't the zero at the three of the beginning be significant? Okay, let's talk about it. It's like this. If I say 0.0003, okay, this means that those are placeholders, and we don't care what happens before you get to a significant digit. So it's almost like if you told me that you took chemistry 11 times, I don't want to know about it. The moment you hit my class, which is the number 3 right there, that's what counts and beyond. Okay. So, in other words, the zeros that come before the significant digit do not count. Okay? Do not count. It's what happens after you have a significant digit, and if there's a decimal placed after that significant digit, that does count. And Daphne says, "Oh, when it considers leading zeros, yes, exactly." So we're gonna go back up here so you all can see the rules. Some of you all may have come in after I was talking about this, and that's okay. So we can actually go back through those again just to refresh your mind. All digits 1 through 9 are inclusive, okay? Zeros that are sandwiched in between other significant digits are also significant. So if I have zeros that are sandwiched in between two other numbers, guess what? Then they are significant. Trailing zeros in a number are significant only if the number contains a decimal point. So if I give you 100.0, there are four significant digits. If I give you 500 with a decimal on the end, there are three significant digits. If I give you 100, 500, 1,000, 10,000, if there isn't a decimal anywhere in that number, then you only have one significant digit, which is the number 1 through 9. So if I give you, let's say, 1,000, like I said before, that's one significant digit. If I give you 10,000, that's still one significant digit. Okay, so Calista says, so if it was 0.03 and a bunch of other zeros, the zeros after the three wouldn't be significant. Actually, they would be. They would be. Let me give you a visual. Okay, you're asking a really good question. And I know a lot of students get this confused. That rule that you just said right there is rule number 5. So 4 and 5 kind of are similar, but let me break it down for you so you can see what I mean by that. I'm glad you're asking these questions. Okay, so here is a good example right here. If I give you 0.0000000000079. Guess what? Only the 7 and 9 count because those zeros come before a significant digit. Before a significant digit. However, if I give you 0.0000000790000, guess what? 7, 9, and the zeros after that 9 do count. So beforehand, don't care. Afterwards, do care. We care about what happens after the decimal with the significant digit, but not before. Okay? I hope that makes sense. I hope that makes better sense. Okay, good, 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 good. Okay, now let's take a look then at going back to where we were previously. Right here, we were on number 8. Okay, number 8. So let's take a look at number 8, where you've got 0.00003. Guess what? Only the 3 counts. Oh, thank you, Callista. Thank you so much for your kind words. Thank you. Thank you. And if you have to take the TEAS exam or the MCAT or any other chemistry class, you come on back so you can get some extra help. Okay? Come on back. So, yes, Daphne, and being correct, number 8 is 1. There's only one significant digit. Very good, guys. Very good. Now, let's take a look at number 9. Number 9, don't let the zeros get you, okay? Remember, they do count if there's a decimal present and it's after a significant digit. Keep that thought in mind. So you've got 0.6050. And let's see, Bean says we have 4 significant digits. Daphne says 4 significant digits. Guess what? You all are right. Excellent job. Good job. We have 4 significant digits. And the reason why we have 4 significant digits is because we know the 6 right here counts. We know the 5 counts. We know this 0 right here sandwiched in between the 6 and the 5 count. But also the 0 that comes after the 5, it counts because of that significant digit value and that decimal. That decimal is there. That what makes it count. Okay? That is what makes it count. So let me give you another example for clarity. 0.6005. Okay, guess what? In this case right here, we know that the 6 0, 0, 5, they count because the zeros are sandwiched in between the 6 and the 5. They're sandwiched in between the 6 and the 5. Even if I put zeros on the very end, guess what? Those zeros would also count. So in this case right here, I would have 6 significant digits. So the decimal that comes here at the very beginning, and if I put all these zeros here, we do not count those. Okay? It's only when you get to the first significant digit and anything that happens after it that does count. Okay? So let's take a look at number 10 now. You've got 25,007. 25,007. So we know that the 2 and the 5 and the 7 are significant. Yes. But right here, you also have some zeros that are sandwiched in between the 5 and the 7. So therefore, those two are going to count. So we have 5 significant digits. 5 significant digits. Okay. Any questions about those examples so far before we get to number 11 and 12? Any questions about those? Okay, Daphne, what happened, honey? What happened? What you got? What's going on? I know you said 3, but what happened? All right. Okay, another good question. In number 4, let's take a look at number 4. Let me write number 4 out. We have 701.0. Okay. The last zero is included because there is a decimal present. It's after a significant digit. So therefore, all of these numbers would count. Okay. So because there's a decimal present and that zero comes after the decimal and it comes after a significant digit, you have to include all of those zeros there. And by the way, this rule goes up here about talks about the zeros. Let me show you because some of you guys may have come in afterwards. Yeah. And when we talked about those zeros, okay? So statements 3, 4, and 5. When you get to chemistry and you all are doing this, make sure you all write these rules down on index cards, okay? What if it was, oh, that's a very good question. So puzzle 4 says, what if the number was, and let me erase this here, and you wrote 710.0. Guess what? In this case right here, all 4 of those numbers would count because there's a decimal present and it's after a significant digit. Okay? There's a decimal present and it's after a significant digit. So I think what we have to, hello, Sonia, what's going on? How you doing tonight? I think what we should do is cover some more of those zero examples because I think so many students are going to have trouble with those if we don't clarify that, okay? Yes, so we go live now. Now that we're here for summer school chemistry, good, good. We're going live uh, Monday, Wednesday. Hold on. Look, I gotta go back to my own schedule because things have changed now that we're in summer school. So it's Monday, Wednesday, Thursday at 12 noon Eastern Standard Time, and Tuesdays and Thursday evenings at 7 p.m. So Monday, Wednesday, Thursday, 12 noon, Tuesdays and Thursdays, 7 to 8. Well, you're on the right track. We're doing significant digits, so you're here right in time, right on time. No, you're good. Matter of fact, this recording is up on YouTube right now. So if you want to go to my YouTube channel, you can actually catch the replay over there on YouTube. So you're good. You are good. Yes. All right. So, and you're right on time because what we're doing, we're actually going to, we're practicing the significant digits rules now. And this is the foundation. This is the very beginning thing of what I teach my students during the summertime for summer school chemistry. So you're right on time. Let's take a look at number 11. You've got 4.25. 4.25. In this case right here, we have three significant digits. Three. And why three? Because the four, the two, and the five are inclusive of digits 1 through 9. Which brings me also to number 12, 6.7. There are only two significant digits there, the 6 and the 7. But I think we need to spend a little more time on the zeros. Mystic said, oh Lord, math, yikes. It's okay. It's okay. Now, whenever we look at scientific notation, um, Daphne, you said so the other numbers don't count? No. So when you talk about scientific notation, 4.25 times 10 to the negative ninth, you are only looking at the base number. The base number is what you go by. So the 4.25 represents three significant digits. If you look at the exponent is telling you to move your decimal to the left 9 times. So you would technically have 9 zeros, 0.0000000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 2, 5. In this case right here, we still will only have three significant digits. Even if this was the number here in decimal form, we would still only have three significant digits. Same thing in number 12. Okay, same thing in number 12. If I were to say 6.7 times 10 to the eighth power, I'm moving my decimal 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. And when I move it 8 places to the right, I am moving my decimal over and filling in those lumps right there with zeros. Okay? But guess what? Only the 6 and the 7 at the very beginning of that number is what counts. So the 6 and the 7 have two significant digits. Okay, my growth journey 24. Why is number 1 only one significant digit? Okay, let's talk about that one as well. All right, and for those of you all that just came in, welcome to the live. My name is Professor TK the Chemist, and I go live different times of the week during the summertime for summer school chemistry. So, what we're doing each week deals with different concepts for summer school. I may be on schedule with your class. I may be ahead or I may be behind. It just depends on when summer school starts for you guys. So, right now we're doing a refresher course for chemistry for summer school. So, this is where you all can ask questions off on what we are talking about. Okay, so take a look at this one. Number 1, the question was, what's happening with number 1? Why is there only one significant digit? Well, remember, the rule says that when you get to a 0, that's at the very beginning of a number and is classified as a placeholder. Let me show you the rules so you will know what I'm talking about. Okay, so right here is rule number 4. Okay, if you look at rule number 4 right here, zeros in the beginning of a number whose only function is to place the decimal are not significant. Trailing zeros are not significant. So the zeros at the beginning do not count. So if I say 0.00000000079, only the 7 and the 9 count. Only the 7 and the 9 count. However, if I have zeros following a decimal, such as rule number 5, zeros following a decimal, and significant digits, then that means significant digits and the zeros after it is what counts. So therefore, I would have 3 significant digits. Okay? That is correct. My growth journey, you are absolutely correct about that. So 0.000490, only the 4, 9, and 0 count, and it has 3. Absolutely correct. That is correct. That is correct. If I have 0.38000, then you have 5 significant digits in that case. Okay, good question. You said, what about, let me write your number down right here. You said, what about 0 point, oh, well, now you can't have 0 point, you can't say 0.3. You're just going to say 3 points. So let me write that again. So if you've got 3.0047, guess what? We know 3, 4, and 7 are significant, right? Because numbers 1 through 9 are significant. But guess what? Because these zeros are sandwiched in between the 3 and the 4, they also will count. So in this case right here, I would have 5 significant digits. Okay? 5 significant digits. So 30047. 5 significant digits. You all are asking some really good questions. And this is why I love doing these lives, because it provides clarity for students who are needing, better help with what they need in terms of what they're doing in chemistry. So don't ever feel like you're embarrassed to ask questions. Ask. I don't mind. I do not mind. I do not mind. Okay. You got another number? You said 3.04706. So guess what? In this case right here, we got the 3, we got the 4, we got the 7, and the 6. And guess what? We know those count, right? But guess what? The zeros also count, because by default, this 0 right here is sandwiched in between 3 and 4. This 0 right here is sandwiched in between 7 and 6. Therefore, you would have 6 significant digits. So you may hear me say significant figures, significant numbers, significant digits, tomato, tomato, pecan, pecan. They mean the same. Okay. You guys are, if you have, we're going to practice some more, because I want to make sure that you guys got this. Okay. So let me go ahead and I'm going to put some more examples here on the board, and you all can tell me what you got. Okay. All right. So let me give you all another example. 1400, 1400 with the decimal on the end, 1400.00. We got 3 examples. 3 examples. Okay. So Al Mengu says, why do we need to know the significant numbers for chemistry? It brings up, it makes numbers more accurate. So like if you're putting numbers on a scale, if you weigh certain things on a scale, okay, it brings the numbers to have more value. And it also represents having numbers that are exact. So, for instance, if I tell you to measure, let's say a powder, or yeah, let's say a powder, and you just put 14, I need to know, is that 14.0 or 14.01 or 14.001? So your scale would render more at the most accurate value within your number. Okay, so this is more or less for um, the accuracy in most of your chemistry labs, and when you're measuring things that need more precision versus accuracy. Okay, more precision versus accuracy. All right. So, yes, go ahead and put your answers in the comment box. I see several of you all got your answers already. So, yes, put them in the order that you know them to be. And make sure you all don't forget to share this live out with other folks you think can benefit from chemistry tutoring, and also the students who you know are taking chemistry that they just don't know that we're here right now. And also, don't forget to tap that screen. Oh, yeah, Al, you know what? I don't miss organic at all. I'm glad you passed that class. I'm glad and biochem, way to go with you with that. Yes. All right. So I see some answers, and everyone did a fantastic job because you got them all correct. In this first example right here, hello, Bingos and Brace. How are you doing tonight? Have you taken your Regents exam yet? In this first example, 1400, that's two significant digits. So you guys got that correct. In the next example, 1400 with a decimal on the end, 4 is also correct. Gotcha. June 24th. Gotcha. And in this last example, 1400.00 gives you 6 significant digits. There you go. So 246. Those are your answers for this example. All right. You know, we got to do some more, right? Because again, Professor TK the Chemist believes in repetition and making sure that you all are doing the right thing. So, hey, thank you, Nietzsche. Thank you for the heart puff. Thank you. Thank you. Appreciate you. So, let's do some more examples. Thank you so much. Let's see here. Okay. I'm going to get you some examples. Let me find some examples. Make sure. Okay. So these are some examples I was working on earlier today. Um, let's see here. Let me scoot this down. Okay, here we go. All right, guys. So we've got some examples here, and I want to see what you all know on these examples for significant digits. Now, remember the zero rule. Remember that, okay? Remember the zeros, and there are several examples with zeros, but don't you stress yourself about these, okay? So let's take a look at the first one, 4.56. How many significant digits are in the first example? 4.56. 3 is correct. The 4, the 5, and the 6. That is correct. 3 is correct. All right. Number 2. You're okay. You're okay. 0.0032. How many significant digits are in that number for number two? 0.0032. All right. If you put two, you are correct. The first zero doesn't count. Right. None of those zeros count. Only the three and the two is what counts. Correct. Remember, leading zeros do not count. The first significant digit that you get to is what counts and beyond. All right. Number three. Number three, 1200. 1200. How many significant digits do you have here? Remember, do you see a decimal present? If not, only the one and the two count. So therefore, you should have two significant digits. All right. Look at number four, 5.00. Remember, you're looking at the base. You're only looking at the base of that number. So don't worry about the exponent part. 5.00 times 10 to the third has is not one significant digit, but instead there are three. There are three significant digits. I knew some of you all would get this one wrong, but remember, the decimal that's there is after a significant digit. Therefore, those zeros would also count. All right. And look at the next one. Let's keep it going. Let's keep it going. Number five. Number five. You've got 0.04050. Correct. Very good, guys. Y'all are doing it good. Doing a good job. That's right. Four significant digits. Only the ones that I'm highlighting are what is considered to be significant. Okay? Number six. Number six. 800. But there's a decimal on the very end. There's a decimal on the very end. So 800, yes. All of those, that's right, the zeros count. So yes, 800 with the decimal on the end means that there are three significant digits. Now, if I did not have that decimal on the end, guess what? Then only the 8 would count. If the decimal was not there, only the 8 would count. Number seven. Number seven. That's right. 444. Yes. If I just had 800, if I just gave you 800 and that was it. Yes. One significant digit. That's right. But because I gave you 800 with the decimal, that's three significant digits. Yes. Okay. Number seven. Yes. I see several of your answers. Many of you all put the correct answer down. 6.070 does have four significant digits. Very good. Four significant digits. All right. Number eight. How many sig figs are in number eight? 0 point, there's a bunch of zeros and then seven. How many sig figs do you see here? Excellent work, guys. Excellent work. That is right. There's one significant digit. Very good. Very good. Number nine. Number nine. How many sig figs do you see there in number nine? Okay, good job. Y'all are on it. Excellent job. Four significant digits. That is correct. Four. And the last one, 1,000 with no decimal point. 1,000 with no decimal point. How many sig figs are there in number 10? Correct. One is correct. Uh-oh, Bean said four. Let's take a look at that one. You've got 1,000. There is no decimal present. Therefore, only the one is significant. Only the one is significant. Okay, okay, okay. You were looking at number nine. Got you, got you, got you. If I give you 123,000, only three significant digits are present. If I give you 75,700, only three significant digits are still present. If I gave you some additional zeros there, you still only have three significant digits. Okay? So, what I want you all to know when you're doing these problems, think about what the rule says and know that it gets better the more you practice. It gets better the more you practice. So, speaking of practice, go back to some of the rules that we talked about tonight. Okay. If you have any chemistry book, you can go back to your rules. And if I were you, I would write these types of rules down on index cards. Okay. And then that way I would be able to do what? Look at them over and over and over again so that I'm mindful of what the rules are. Because sometimes you get the rules confused. You get the rules confused. And you can also, create these index cards, get a pack of them from Dollar Tree, and then just write the rule on one side and put several examples on the other side so that they become repetitious for you. Okay. So those of you all that joined me tonight, we were only working on significant digits. I was introducing to you all significant digit rules so that you would know what to do when it comes to your significant numbers for chemistry. Chemistry is one of those things that you have to practice every day, especially when you're taking this during summer school. Now, if you're taking this during the summer and it's a 5 or 8 week course, you need to look at chemistry at least 2 hours a day. That's minimum. But I'm not talking about 2 hours straight. I'm saying the Pomodoro effect, where you're studying for like 20 minutes, take a 5 minute break, come back 20 minutes again, 5 minute break, so that you're breaking it up in smaller pieces to help you remember the information. You don't want to sit down and just drill yourself for 2 hours because sometimes that will make learning this more tedious. Okay. This is new for a lot of students. And because it's new, students get confused with what they have to know. Okay. So if you all want to join me again when we do these lessons, we will be going live for summer school chemistry. Let me give you all my schedule again in case you all just came in. And it's also pinned up. Well, it's not pinned yet, but it's the last video I posted Monday, Wednesday, Thursday, 12 noon. So we're having lunch and learn at 12 noon Eastern Standard Time. Now, tomorrow I will not be going live at 12 noon, but I will be live on Tuesdays and Thursdays at 7 p.m. Eastern Standard Time. Okay. 7 p.m. Eastern Standard Time. So I thank you guys so much for joining me. If you want to get this live, it is on my YouTube channel. So I was going live as we were doing this on YouTube as well, guys. So I thank you all so much for joining me, and I look forward to meeting you guys every week. Okay, and thank you so much, 444 for posting that. You're welcome. Yes, see you all next time. And listen, we play games also. I go on Kahoot. Thank you so much, Nietzsche, for the heart puffs as well. I go on Kahoot and we play games. So if you all want to be a part of the game time, that's usually at the end of the week so that we can have a good time recapturing everything that we've learned thus far. Okay? So you guys take care and I will see you all Thursday. All right. Take care, guys.